June 9th, 1944. Somewhere in the Norman Bocage, Oberstleutnant Friedrich Weber of the Wehrmacht's Pioneer Corps stood in what remained of a French apple orchard, studying aerial reconnaissance photographs that made no sense. The images, taken by a Luftwaffe Focke-Wulf 190 over the American beachhead at Omaha, showed something that violated every principle of military engineering he'd learned in 2 decades of service. The photographs were dated June 8th, just 2 days after the Allied invasion. They showed a flat, cleared area near Colleville-sur-Mer, approximately 300 meters long and 60 meters wide. Raw earth, obviously freshly graded. No structures, no paved surface, just dirt. Weber had marked it in his log as insignificant, probably a supply dump or vehicle assembly area, nothing tactical. The new photographs, taken June 9th at 0700 hours, showed the same location. Except now it had a runway, not a rough landing strip. An actual operational airfield with what appeared to be a hard surface capable of supporting fighter aircraft. American P-47 Thunderbolts were visible on the ground. Tire tracks indicated multiple aircraft had already landed and departed. Weber checked the dates again. 24 hours. The Americans had constructed an operational military airfield in 24 hours. His hand holding the photographs trembled slightly, though not from fear, from the realization that everything the German High Command believed about the pace of modern warfare might be catastrophically wrong. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Weber had spent 3 years on the Eastern Front, where German pioneer units were considered among the finest combat engineers in the world. He had personally overseen the construction of field airstrips near Kharkov in 1942, working with experienced crews using the best equipment the Wehrmacht could provide. Those airstrips, built on relatively flat Ukrainian steppe with favorable soil conditions and no enemy interference, had taken between 12 and 16 days from initial survey to operational status. The Americans had just done it in 1 day, on hostile ground, under German artillery observation, in terrain that, according to every French soil survey map Weber had studied, consisted of Norman clay that turned to soup in wet weather. The mathematical impossibility of what he was looking at made his engineering education revolt against the evidence of his own eyes. This is the story of how American construction speed became a weapon of war that German military planners never anticipated. It's about the collision between methodical European military engineering and American industrial improvisation. It's about bulldozers that moved earth faster than anyone thought possible, about construction battalions that worked through the night under blackout conditions, and about how the ability to build an airfield in 72 hours changed the fundamental calculus of the Normandy campaign. It's about German assumptions shattered by American machines. October 17, 1942, Sweetwater, Texas. The U.S. Army Corps of Engineers opened the Engineer Aviation Training Center, a sprawling facility designed to produce specialized construction units at a scale never before attempted. The mission was specific: train, engineer, aviation battalions capable of rapidly constructing airfields under combat conditions anywhere in the world. The concept emerged from painful lessons learned in the first year of the war. When American forces deployed to the Pacific and North Africa, they discovered that traditional peacetime construction methods were utterly inadequate for combat operations. Building an airfield, the Army Air Corps way, following pre-war engineering manuals, required extensive soil surveys, careful site selection, precise grading specifications, and construction timelines measured in months. The enemy, it turned out, did not respect construction schedules. Japanese aircraft attacked partially completed runways. German bombers targeted airfield construction sites. The critical realization came in early 1942. In modern warfare, the side that could establish air superiority fastest won the ground campaign. And air superiority required runways, lots of them, built quickly. The training at Sweetwater reflected this urgency. Unlike regular engineer units, which spent weeks on military drill and tactics, aviation engineer battalions compressed basic training into 3 weeks, then dedicated the bulk of their instruction to construction speed techniques. Recruits learned to operate bulldozers, graders, rollers, and carryalls with an emphasis on continuous operation, night and day, in dust and mud. Under simulated combat stress, Captain Robert Morrison of the 834th Engineer Aviation Battalion, a former highway construction supervisor from Michigan, later described the training philosophy. They weren't teaching us to build perfect runways. They were teaching us to build functional runways as fast as humanly possible. If it could handle aircraft for 6 months, that was good enough. If it took more than a week to build, it was too slow. The equipment that these battalions received was unlike anything European military engineers possessed. American industry, already mobilized for wartime production, was churning out construction machinery at a scale that seemed excessive even by American standards. Each engineer aviation battalion received an authorized equipment inventory that read like a construction company's wish list. Standard allocation for an 800-man battalion included 18 Caterpillar D7 bulldozers with 6-way blades, 12 Caterpillar diesel graders with 14-foot moldboards, 8 Galion diesel rollers, each weighing 12 tons, 16 International carry-all scrapers with 7 cubic yard capacity, 6 Letourneau routers for clearing heavy vegetation, 4 Adams concrete mixers, 6 air compressors with jackhammer attachments, 23 diesel-powered generators, and 98 trucks of various capacities, from half-ton pickups to 10-ton cargo haulers. The total equipment value per battalion exceeded $2.3 million in 1942 currency, more than the cost of equipping an entire infantry regiment. The emphasis on mechanization was absolute, where European military doctrine still relied heavily on manual labor, supplemented by machinery. American aviation engineer battalions were designed around the assumption that machines would do nearly all the heavy work. The men operated the machines moved the earth. This wasn't entirely new. American civilian construction had been highly mechanized since the 1920s, particularly in the western states where vast distances and harsh terrain demanded efficient earth-moving. What was revolutionary was applying industrial construction techniques to military operations with explicit acceptance that speed mattered more than perfection. Private First Class James Chen, who joined the 816th Engineer Aviation Battalion in January 1943, came from a family that had worked on Grand Coulee Dam. He recalled the equipment briefing during training. The sergeant told us that one D7 bulldozer could move more earth in an hour than 50 men with shovels could move in a day. Then he said our job was to keep those machines running 24 hours straight until the runway was done. We'd work in shifts, but the machines never stopped. The bulldozers deserved particular attention because they became the signature weapon, if you could call it that, of American engineer battalions. The Caterpillar D7, which entered full production in 1941, represented the culmination of decades of American earth-moving innovation. It weighed approximately 22,000 pounds, generated 80 horsepower from its diesel engine, and could push loads of approximately 15 cubic yards with its 6-way hydraulic blade. That blade was the key feature. Unlike fixed blades that could only push straight ahead, the D7's blade could be angled, tilted, and raised hydraulically, allowing the operator to grade, level, cut trenches, and backfill without stopping. A skilled operator could perform grading work that would have required multiple specialized machines just a decade earlier. The Germans had nothing comparable. The Wehrmacht Pioneer Corps used a mix of equipment, primarily French Renault tractors captured in 1940, some Italian Fiat agricultural tractors, and limited numbers of German Hanomag tracked vehicles. These machines were functional but underpowered, typically generating between 30 and 50 horsepower. More critically, German military doctrine viewed mechanized equipment as supplementary to manual labor rather than primary. German engineer training emphasized precision and thoroughness. A German pioneer platoon constructing an airfield would begin with detailed topographic surveys, soil testing, drainage calculations, and engineered solutions to every construction challenge. The resulting airfield would be superbly built, meeting exacting standards. It would also take 3 to 4 weeks minimum, assuming no interruptions. This wasn't incompetence. It was a different philosophy rooted in European military tradition that valued proper engineering over expedient construction. German officers were trained to believe that hastily built infrastructure would fail under operational stress, causing more problems than it solved. Better to build it right the first time, even if it took longer. American engineer doctrine had reached the opposite conclusion. Build it fast. If it fails, fix it. If it needs improvement, improve it. But get aircraft operational immediately because the tactical situation won't wait for perfect engineering. The clash of these philosophies would become apparent in Normandy, but the German High Command had already received warnings they chose not to believe. North Africa provided the first evidence. When American forces landed in Morocco and Algeria during Operation Torch in November 1942, German intelligence officers noted with interest that American engineers constructed airfields at Maison Blanche near Algiers with unusual speed. A Luftwaffe reconnaissance report from December 1942 documented that the Americans completed a fighter strip near Oran in 7 days. The report was filed with a notation suggesting that the Americans must have utilized local civilian contractors and pre-positioned materials. The alternative that they had simply worked faster was considered unlikely. In Sicily, July 1943, the pattern repeated. The 813th Engineer Aviation Battalion landed near Gela on July 10th, the day of the invasion. By July 14th, they had completed a runway at Ponte Olivo airfield capable of handling P-38 fighters. German reports again attributed this to pre-invasion preparation, suggesting that Italian collaborators must have done preliminary work. The possibility that American engineers were genuinely constructing airfields 3 to 4 times faster than German engineers could was never seriously considered at high levels of Wehrmacht command. It contradicted established military engineering wisdom. It seemed more plausible that American reports were exaggerated for propaganda purposes. General Feldmarschall Erwin Rommel, preparing defenses along the Atlantic Wall in early 1944, received intelligence briefings about American engineer capabilities. His defensive planning assumed that even if the Allies achieved a Prada successful landing, they would require a minimum 10 to 14 days to establish functional airfields inland. This assumption shaped the entire German defensive strategy in Normandy. The plan was straightforward. German forces would contain the Allied beachhead, preventing rapid breakout. Strong defensive positions inland would delay American advances. Luftwaffe bombers, operating from bases in northern France, would attack Allied supply lines and troop concentrations. Panzer divisions held in reserve would counterattack once Allied forces were fixed in place. All of this depended on the Allies being unable to establish close air support quickly. If the Americans needed 2 weeks to build airfields, German forces would have time to organize coordinated counterattacks. The Luftwaffe, despite being outnumbered, could still contest airspace over the beachhead if Allied fighters had to fly from distant bases in England. Rommel's engineers calculated that the Norman terrain would work in Germany's favor. The Bocage country, with its ancient hedgerows, sunken roads, and small irregular fields, was a terrible tank country but also terrible for rapid construction. The clay-heavy soil had poor drainage. Summer rains could turn construction sites into morasses. Finding suitable locations for airfields would be difficult. Clearing and grading would be time-consuming. These were not unreasonable assumptions. They were based on sound engineering principles and historical experience. What Rommel and his staff failed to account for was that American engineers weren't following European engineering principles. They were following American industrial logic that treated Earth like any other material to be processed, moved, and shaped with maximum mechanical efficiency. The doctrinal difference ran deeper than just equipment. German military engineering was a branch of the profession of engineering, with officers typically holding university degrees in civil engineering and enlisted men selected for technical aptitude. Construction projects were carefully managed with proper supervision, quality control, and adherence to engineering specifications. American engineer aviation battalions, recruited from civilian construction workers, equipment operators, and surveyors who had learned their trade by doing, not by studying. Officers often had construction management experience rather than engineering degrees. The emphasis was on practical results. Can aircraft land on it? Can it support repeated operations? If yes, it's good enough. Move to the next project. This pragmatism extended to material choices. German engineers preferred proper concrete runways whenever possible, viewing them as permanent solutions that would serve for years. American engineers used whatever materials were available and fastest to install: compacted earth, crushed stone, pierced steel planking, or asphalt if possible. The runway didn't need to last for years. It needed to last until the front moved forward and new runways were built closer to the fighting. The American doctrine of continuous forward movement, building temporary infrastructure that would be abandoned as forces advanced, was alien to German military thinking. German forces built to hold ground permanently. Infrastructure was meant to endure. The idea of constructing an airfield you intended to use for only 6 weeks seemed wasteful. But waste, by European standards, was baked into American military logistics. American forces operated with material abundance that shocked German observers whenever they captured supply dumps. The United States was producing construction equipment, vehicles, and materials at rates that made temporary installations acceptable. You could afford to leave behind bulldozers and generators if advancing rapidly mattered more than conserving equipment. This material abundance extended to personnel. Engineer aviation battalions were large units, typically 800 men, far larger than equivalent German pioneer companies of 150 to 200 men. More men meant work could continue around the clock in multiple shifts. German units, constrained by manpower shortages, typically worked single shifts with occasional double shifts for urgent projects. The combination of more men, more machines, different doctrine, and willingness to accept temporary solutions created a construction capability that German intelligence analysts had no framework to properly evaluate. The numbers they received seemed implausible. Airfields in 3 to 5 days? Impossible. Must be counting from different starting points or including preparation time. As German forces waited behind the Atlantic Wall in June 1944, their defensive calculations rested on assumptions about construction timelines that were about to be comprehensively demolished. Oberstleutnant Weber, studying those reconnaissance photographs in the Norman apple orchard, was beginning to understand what his superiors had not yet grasped. The Americans weren't just faster builders. They had fundamentally reconceptualized military construction as an extension of industrial mass production. They were treating airfield construction like an assembly line process, standardized procedures, specialized equipment, continuous operation, and acceptance that the product only needed to meet minimum functionality, not optimal specifications. Weber folded the photographs and placed them in his map case. He would include them in his report to divisional headquarters, though he doubted anyone would believe his assessment. The Americans, he would write, are not building airfields in the traditional sense. They are manufacturing them. This represents a capability we have not adequately prepared to counter. He was right, and within weeks, the consequences of that failure would reshape the entire Normandy campaign. The German assumption that Allied air power would be limited by infrastructure construction timelines was about to collide with American bulldozers that never stopped moving Earth. June 7, 1944. Plus, one day after D-Day, the 834th Engineer Aviation Battalion waded ashore at Omaha Beach while German artillery still pounded the shoreline. These men weren't infantry, though they carried rifles and knew how to use them. They were construction workers in uniform, and their mission was arguably more critical than capturing ground. They had to build the infrastructure that would allow Allied air power to support the ground offensive. The battalion came ashore with a detailed plan that had been rehearsed repeatedly in England. Their objective was designated Advanced Landing Ground A1, a site approximately 3 kilometers inland near the village of Saint-Laurent-sur-Mer. According to pre-invasion aerial reconnaissance, the location offered relatively flat terrain suitable for rapid runway construction. What the reconnaissance photographs couldn't show was whether German forces still occupied the area or whether the soil would support heavy equipment. Company A hit the beach at 08:30 hours. Instead of moving inland immediately, they began the unglamorous but essential work of clearing beach obstacles to create paths for their heavy equipment. Bulldozers were loaded on landing ship tanks that couldn't beach until engineers cleared approach routes. Every minute spent on the beach was time under German fire, but without the bulldozers inland, there would be no airfield. By 1400 hours, the first D7 bulldozers rolled off LSTs and began climbing the bluffs behind Omaha Beach. Sergeant Harold Peterson, a bulldozer operator from Oregon who had spent 6 years building logging roads before the war, later described the experience in a letter home. "We went up those bluffs with German machine guns still firing from positions we hadn't cleared yet. I kept my head down and just kept the blade moving. You don't think about it. You just drive." The battalion's advance party reached the ALG A1 site at 1600 hours on June 7th. German forces had retreated, but they had left behind a landscape deliberately devastated. Every tree had been felled and left lying across the proposed runway area. Drainage ditches had been dug to create water-filled obstacles. The Germans, operating on their assumption that airfield construction would take weeks, had created obstacles designed to delay American engineers. They had not anticipated that the Americans would simply push through these obstacles with overwhelming mechanical force. Lieutenant Colonel Kenneth Campbell, the battalion commander, surveyed the site and made an immediate decision that violated every conventional engineering principle. They would not clear the obstacles first and then begin grading. They would do both simultaneously. Bulldozers would push the felled trees into windrows along the runway edges, while graders worked behind them, shaping the surface. Time spent on sequential operations was time the infantry spent without air support. The 834th operated on a shift system that kept equipment running 24 hours per day. 3 8-hour shifts, with each operator responsible for a specific machine. When shift change came, the replacement operator climbed aboard while the machine was still running. The engine never stopped. Fuel trucks moved continuously between the worksite and fuel dumps on the beach. Maintenance crews performed repairs in the field, often working by flashlight under blackout conditions. The noise was constant and overwhelming. 18 bulldozers, 12 graders, 8 rollers, and dozens of trucks created a mechanical symphony that could be heard for kilometers. German artillery observers could track the construction progress by sound alone. Shells began falling on the site at 1900 hours on June 7th, a bombardment that would continue intermittently for the next 4 days. The engineers worked through it. When shells landed near the runway, men took cover in slit trenches hastily dug around the perimeter. When the barrage lifted, they returned to their machines. Casualties were inevitable. Private First Class Thomas Brennan, a 23-year-old grader operator from Boston, was killed by shrapnel on the evening of June 8th. His machine was back in operation 30 minutes later with a replacement operator. The mission deadline did not accommodate grief. By the morning of June 9th, 72 hours after landing, the 834th had completed a runway measuring 3,400 feet long and 120 feet wide. The surface was compacted earth, reinforced with crushed stone quarried from a nearby hillside. It wasn't elegant. The grade had variations that would have been unacceptable on a peacetime airfield. Drainage was adequate but not optimal. By German engineering standards, it was rough work. But at 09:30 hours on June 9th, a P-47 Thunderbolt of the 365th Fighter Group touched down on ALG-A1, the first Allied fighter to land in France since 1940. The pilot, Captain James Tucker, climbed out of his cockpit and walked the length of the runway, examining the surface. His report to group operations was succinct. "It'll do. We can operate from here." By that afternoon, the entire 365th Fighter Group had relocated from England to ALG-A1. 48 Thunderbolts are now based 3 kilometers from the front lines instead of 180 kilometers away across the English Channel. Their response time to ground support requests dropped from 45 minutes to 8 minutes. That difference was measured in saved lives on the ground. German commanders watching this unfold struggled to comprehend what they were seeing. Oberst Werner von Haking, commanding artillery positions observing the American beachhead, reported to 7th Army headquarters on June 10th that the Americans appeared to have an operational airfield near Saint-Laurent. The response from headquarters was skeptical. "Confirm this report. It is not possible to construct an airfield in 3 days. Von Haking's reply was bitter. "I am watching American fighters take off from it. Whether it is possible or not, they have done it." The 834th wasn't finished. While Company A maintained ALG-A1, Company B moved forward on June 10th to begin work on ALG-A2 near Crickerville. The pattern repeated: site selection based on quick reconnaissance, minimal clearing, immediate grading with bulldozers working in parallel, and continuous operation under fire. ALG-A2 was operational by June 13th, 3 days, site to operational status. By June 20th, 2 weeks after D-Day, the IX Engineer Command had completed 6 advanced landing grounds in the American sector. The RAF's 2nd Tactical Air Force had completed 4 more in the British sector. 10 operational airfields where German planners expected 0. The Luftwaffe, already heavily outnumbered, now faced Allied fighters operating from bases so close to the front that German bombers couldn't reach them without running a gauntlet of Allied air patrols. The construction techniques that enabled this speed were specific and deliberate. American doctrine called for minimum acceptable standards rather than optimal ones. A fighter strip required 3,000 feet of runway capable of supporting aircraft weighing up to 12,000 pounds. That was the specification. Anything beyond that was unnecessary and time-consuming. Grading was performed to what engineers called rough level, meaning variations of up to 6 inches over 100 feet were acceptable. On peacetime airfields, specifications demanded variations of no more than 1 inch over 100 feet. The difference was the margin between 1 day of grading work and 5 days of grading work. Fighter pilots adapted to the rough surfaces without complaint. A bumpy takeoff was infinitely preferable to no takeoff. Drainage systems were rudimentary. Instead of engineered French drains and culverts, American engineers simply graded to create surface runoff, cutting shallow ditches along runway edges to channel water away. If heavy rains created standing water, bulldozers returned and regraded. The runway was maintained continuously rather than built once to perfect specifications. Surface materials depended entirely on what was available locally. In Normandy, most ALGs used compacted earth mixed with crushed stone. Engineers discovered that Norman clay, which turned to mud when saturated, could be stabilized by mixing in crushed limestone. The limestone created a matrix that prevented the clay from becoming plastic. Bulldozers would cut into hillsides, exposing limestone deposits. Other bulldozers would push the limestone onto the runway surface. Graders mixed it with existing soil. Rollers compacted everything into a surprisingly durable surface. When local materials were inadequate, engineers used pierced steel planking, the famous Marston mat that had proven itself in the Pacific. PSP could be laid at approximately 500 linear feet per day by a trained crew. A 3,000-foot runway using PSP required 6 days under good conditions. But PSP was heavy, required shipping space, and represented significant material investment. American doctrine preferred using local materials whenever possible, saving PSP for locations where soil conditions made it necessary. The speed advantage wasn't just about equipment and materials, it was about accepting risk. German engineers would halt work if soil conditions seemed marginal, conducting additional testing and analysis to ensure the runway would safely support aircraft operations. American engineers built the runway and tested it by landing aircraft on it. If it held, it was good enough. If it failed, they fixed the failure and continued operations. This willingness to test infrastructure under operational conditions rather than through theoretical analysis saved enormous amounts of time. An example from ALG A4 near Deux Jumeaux illustrates the principle. The 816th Engineer Aviation Battalion completed initial grading on June 18th, and the battalion commander wanted to verify the surface would support P-47 operations before declaring it operational. Instead of conducting soil-bearing tests, which would have required specialized equipment and analysis, they simply asked a fighter pilot to land on it. Captain Richard Nelson of the 373rd Fighter Group volunteered. He made 3 landings, each one progressively harder to stress the surface. The runway held, declared operational. Total testing time, 45 minutes. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The German response to this construction pace was hamstrung by limited resources and conflicting priorities. Luftwaffe bombers attempted to attack the new Allied airfields, but reaching them required flying through Allied fighter screens that were now operating from those same forward bases. The defensive circle had inverted. Instead of Allied fighters stretching to provide coverage over the beachhead, they were now based within the beachhead, creating a defensive umbrella that German aircraft couldn't penetrate. German artillery could reach some of the forward ALGs, and they pounded them continuously. But here the American construction doctrine proved its value. Artillery could crater runways, but craters could be filled and resurfaced in hours. The 834th Engineer Aviation Battalion kept repair crews on standby, specifically for this purpose. When German shells created craters, bulldozers pushed earth into them, graders smoothed the surface, rollers compacted it, and aircraft resumed operations. The entire repair cycle took between 2 and 6 hours depending on crater size. German forces, watching this rapid repair cycle, effectively gave up on artillery interdiction of American airfields by late June. The shells expended, trying to close a runway that would reopen within hours, were shells that could have been used against infantry positions or supply columns. It was a losing exchange. The broader strategic implications became apparent by early July 1944. Allied forces were expanding the Normandy beachhead faster than German commanders had believed possible. and the primary enabler wasn't armor or infantry. It was air superiority maintained by fighters and fighter bombers operating from hastily constructed forward airfields. German counterattacks, which doctrine said should be conducted rapidly with concentrated armor, were being detected and disrupted by Allied aircraft before they could achieve concentration. Panzer columns moving toward the front were strafed by P-47s and Thunderbolts operating from bases 20 kilometers away. Supply convoys were forced to move only at night, and even then, they faced aircraft equipped with radar and searchlights. By July 15, 1944, the IX Engineer Command had completed 15 advanced landing grounds in Normandy. Fighter groups were rotating between them, using the forward ALGs for maximum time on station over the front lines, then returning to more established bases in the rear for maintenance and resupply. The operational flexibility this network provided was something German forces had no counter for. General Feldmarschall Günther von Kluge, who replaced Rommel as commander of German forces in Normandy after Rommel was wounded on July 17, inherited a tactical situation shaped by infrastructure construction, timelines he hadn't anticipated. His after-action reports to OKW, the German Armed Forces High Command, were blunt. The Americans are constructing airfields faster than we can destroy them. Their close air support is decisive. Our mobile operations are effectively impossible during daylight hours. The breaking point came during Operation Cobra, the American breakout from the Normandy beachhead beginning July 25, 1944. The operation was preceded by carpet bombing that devastated German defensive positions, delivered by aircraft operating from bases that hadn't existed a month earlier. When American armor broke through German lines, Allied fighters provided continuous cover, interrupting any German attempt to establish new defensive positions. German forces retreated eastward, but they couldn't retreat faster than American engineers advanced. The 834th Engineer Aviation Battalion moved forward with the advancing infantry, identifying and preparing new airfield sites even before German forces had fully evacuated the area. ALG A-15 near Lessay was under construction, while German artillery was still firing from positions 8 kilometers away. The pattern that had emerged in Normandy repeated itself across France during the summer and autumn of 1944. As Allied forces broke out of the beachhead and drove toward the German border, engineer aviation battalions moved with them, creating a rolling network of temporary airfields that supported the advance. The German military term for this phenomenon was Rollbahn-Luftwaffe, runway air force, a recognition that American air power was no longer tied to permanent bases, but could relocate as quickly as ground forces advanced. The statistics from the European theater tell the story more clearly than any narrative description. Between D-Day on June 6 and the end of August 1944, engineer aviation battalions constructed or rehabilitated 63 airfields in France. That's one new operational airfield every 0.4 days for 3 months straight. By comparison, the Luftwaffe in 1940, during the height of German military success, averaged one new airfield every 8 days during the Battle of France. The construction pace accelerated as Allied forces pushed into Belgium and Luxembourg. The 816th Engineer Aviation Battalion completed 8 supply and evacuation strips in just 3 days during September 1944, supporting the advance toward the German border. These weren't full tactical airfields. They were emergency strips, approximately 1,500 feet long, designed for liaison aircraft, medical evacuation flights, and emergency landings, but they extended the operational reach of Allied air power in ways German planners had never anticipated. By November 1944, when the Allied advance stalled along the German border due to supply constraints, engineer aviation battalions had constructed more than 280 airfields in continental Europe. The scale of this infrastructure project was unprecedented. It represented more runway construction in 5 months than the entire German road and rail network expansion during 3 years of pre-war preparation. The implications went beyond tactical air support. The rapid construction capability fundamentally altered how the Allies could project power. Strategic bombers, previously limited to operating from established bases in England, could now stage through forward bases in France, reducing flight times and increasing bomb loads. Fighter escorts could land at forward strips, refuel, and rejoin bomber formations, extending their range. The entire architecture of Allied air operations transformed because infrastructure could be created on demand rather than planned years in advance. German military analysts, examining captured American engineering manuals after the war, were struck by how completely different the American approach was from German doctrine. A 1947 study by the U.S. Strategic Bombing Survey interviewed former Wehrmacht officers about their perceptions of American engineering capabilities. General Major Alfred Toppy, who had served as an operations officer in Normandy, provided a representative assessment. "We were trained to believe that proper military engineering required time, resources, and careful planning. The Americans demonstrated that speed could substitute for all three. Their engineers didn't build perfect airfields. They built adequate airfields quickly, and then they made them better while using them. This approach was foreign to our thinking. We would never have declared an airfield operational until it met all specifications. The Americans declared it operational when the first aircraft landed successfully. That difference in philosophy cost us the air superiority battle. The human cost of this construction effort was significant, but often overlooked in histories that focus on combat operations. Engineer aviation battalions suffered casualties from enemy action, accidents with heavy machinery, and diseases contracted while working in unsanitary conditions. The 834th Engineer Aviation Battalion, which built more airfields in Normandy than any other unit, lost 43 men killed and 117 wounded between D-Day and VE Day. Most of these casualties occurred during construction operations, not combat. Private First Class Michael Torres, a bulldozer operator with the 816th, was killed on July 8, 1944, when his machine rolled down an embankment during night operations near Carrington. Sergeant Harold Peterson, the Oregon logger who had driven bulldozers up the Omaha Beach bluffs on D-Day, was severely wounded by German artillery fire on August 3rd while grading a runway near Avranches. He survived but lost his left leg below the knee. These men weren't heroes, in the traditional sense. They didn't storm enemy positions or fight desperate last stands. They operated bulldozers and graders under fire. They worked 20-hour shifts. They slept in muddy foxholes and ate cold rations. Their names don't appear in the major histories of the Normandy campaign. But without their work, the campaign would have unfolded very differently, probably taking months longer and costing thousands of additional casualties. The technological legacy of American rapid airfield construction influenced post-war military doctrine worldwide. The Soviet Union, studying American engineer methods, reorganized its own military construction units along similar lines, emphasizing mechanization and speed over precision. The Red Army's advance into Eastern Europe in 1945 employed engineer units that operated on principles borrowed directly from American practice, though Soviet equipment remained inferior in quality and quantity. The French military, rebuilding after liberation, adopted American construction standards for their airfields rather than reverting to pre-war French specifications. The Royal Air Force, which had initially been skeptical of American rough-and-ready construction methods, incorporated rapid runway construction into their doctrine for overseas operations. The American approach became the international standard not because it was theoretically superior, but because it had been proven effective under combat conditions. The equipment innovations pioneered during the war transformed civilian construction. Caterpillar and other manufacturers found enormous post-war markets for the bulldozers and graders that had proven themselves in military service. The techniques developed for rapid grading under combat pressure influenced highway construction, dam building, and suburban development across America in the 1950s. Interstate highway construction in particular benefited from engineering methods refined during wartime airfield building. One unexpected legacy was environmental. The American doctrine of building temporary infrastructure that could be abandoned without massive investment meant that many wartime airfields in France simply returned to agricultural use after the war. Unlike permanent concrete installations that required demolition, the compacted earth and crushed stone runways gradually degraded back into fields. Farmers plowing former airfields in Normandy would occasionally uncover pierced steel planking buried under topsoil, physical reminders of temporary installations that had served their purpose and been deliberately allowed to fade away. By contrast, German airfields in France, built to permanent specifications with concrete runways and extensive underground facilities, required years of demolition work after the war. Some remain visible today as industrial sites or storage facilities, too expensive to remove completely. The irony was sharp. German engineering, designed for permanence, created obstacles that outlasted their utility. American engineering, designed for expedience, accomplished its mission and vanished. The story of Oberstleutnant Weber provides a human bookend to this narrative. After the war, he was briefly held as a prisoner of war and interviewed by American military intelligence officers interested in German perceptions of Allied capabilities. The interview transcript, preserved in National Archives records, shows Weber had spent considerable time thinking about what he had witnessed in Normandy. An intelligence officer asked him when he realized Germany would lose the war. Weber's response was specific. "When I saw that the Americans could build an airfield in one day, I knew we had fundamentally misunderstood the nature of modern warfare. We believed engineering was about perfection. The Americans understood it was about speed. That difference meant they could bring overwhelming force to bear faster than we could react. After that, the outcome was inevitable." Weber returned to civilian life in Germany, working as a civil engineer during the Reconstruction period. He reportedly kept a framed copy of those June 9th reconnaissance photographs in his office, the images that had first shown him an American airfield appearing overnight. Colleagues asked why he would display a reminder of German defeat. His answer, according to his son's memoir published in 1988, was illuminating. "It's not a reminder of defeat. It's a reminder that assumptions can be more dangerous than enemy action. We assumed the Americans would build slowly because we built slowly. We were wrong, and that mistake cost us the war." The broader lesson extends beyond World War II engineering. Military organizations, like all large institutions, tend to assume that their adversaries operate according to similar principles and constraints. The Germans assumed American engineers would be limited by the same factors that limited German engineers: proper training, adequate planning time, and commitment to engineering standards. They were correct about the first two and completely wrong about the third. American engineers weren't better trained than German engineers in the technical sense. German engineering education was arguably more rigorous. American engineers didn't have more planning time. They often had less. But American engineers operated under a different set of institutional values that prioritized mission accomplishment over technical perfection. That difference, multiplied across hundreds of construction projects over 2 years of war, became strategically decisive. The bulldozers themselves became symbols of American industrial power in a way their manufacturers never anticipated. The Caterpillar D7, designed for civilian construction work, became as iconic in its way as the Sherman tank or the P-51 Mustang. German soldiers came to recognize the sound of American bulldozers operating at night as a signal that a new Allied airfield was being built, which meant increased Allied air attacks would follow within days. The psychological impact was measurable. German units could fight against tanks and infantry with some hope of success. Fighting against an enemy that could establish air superiority anywhere they wanted within 72 hours was a different problem with no doctrinal solution. Post-war analyses by military historians have attempted to quantify the strategic value of rapid airfield construction. The calculations are necessarily imprecise, but most estimates suggest that American construction speed shortened the European campaign by between 3 and 6 months. That time frame represents thousands of lives saved, both military and civilian. It represents months less of German occupation in France, Belgium, and the Netherlands. It represents an earlier end to the Holocaust as concentration camps were liberated. Infrastructure doesn't win wars in the dramatic sense. You can't point to a specific bulldozer and say that machine defeated Germany. But wars are systems of interconnected capabilities, and infrastructure provides the foundation on which all other capabilities rest. Aircraft need runways. Armor needs fuel and ammunition. Infantry needs supply lines. The side that can create infrastructure faster can operate more aggressively, take more risks, and exploit opportunities that would be impossible for a slower-moving enemy. The legacy continues in modern military operations. When American forces deploy to crisis zones today, engineer units modeled on World War II, aviation engineer battalions arrive in the first waves. The equipment is more sophisticated. Modern bulldozers have GPS guidance and laser grading systems, but the fundamental mission remains identical. Build infrastructure fast enough to support combat operations. Accepting that adequacy achieved quickly is more valuable than perfection achieved slowly. The U.S. Air Force's Red Horse squadrons, Rapid Engineer, deployable heavy operational repair squadron engineers, trace their institutional lineage directly to the engineer aviation battalions of World War II. Their motto, Construmus Batuimus, we build, we fight, encapsulates the dual nature of military construction under combat conditions. The Navy's construction battalions, the Seabees, maintain the same tradition in maritime environments. When coalition forces invaded Iraq in 2003, engineer units constructed forward operating bases and airfields using methods and doctrine that would have been recognizable to veterans of the 834th Engineer Aviation Battalion. Bulldozers graded runways in days. Aircraft began operations before construction was complete. Facilities were built to minimum acceptable standards rather than optimal specifications. The principles proven in Normandy remained valid 60 years later. The story of German engineers underestimating American bulldozers is ultimately a story about institutional culture and strategic assumptions. Military organizations develop doctrine based on their own capabilities and limitations, then assume adversaries operate under similar constraints. This is logical but dangerous. The Germans had excellent reasons to believe airfield construction required 2 to 3 weeks minimum. All of their experience supported that timeline. The problem was that American experience, shaped by different industrial capabilities and different cultural attitudes toward temporary infrastructure, had produced entirely different timelines. Breaking free of institutional assumptions is extraordinarily difficult. It requires leaders willing to question fundamental beliefs, intelligence organizations capable of crediting information that contradicts existing doctrine, and flexibility to adapt when reality doesn't match expectations. German military leadership in 1944 possessed many strengths: tactical competence, operational experience, and technical expertise among them. What they lacked was the institutional flexibility to recognize that their assumptions about construction timelines were wrong until those wrong assumptions had already shaped losing strategies. American engineer aviation battalions didn't set out to revolutionize warfare. They were construction workers trying to complete their assigned missions under difficult conditions. But in aggregate, their work created a capability that German planning had failed to anticipate. Airfields appearing in 72 hours. Runways operational before German forces could adjust their defensive positions. Air superiority was established faster than doctrine said was possible. These outcomes cascaded into strategic effects that shaped the entire campaign. The bulldozers that German engineers never imagined could build airstrips in 72 hours flat did exactly that, repeatedly, across France, Belgium, Luxembourg, and into Germany itself. They did it not through technical superiority in the traditional sense, but through a different approach to what military construction should prioritize. Speed over perfection, function over form, mission accomplishment over adherence to peacetime engineering standards. That approach, tested under fire in the Pacific and proven in Normandy, became a permanent feature of how modern militaries think about infrastructure and logistics. The lesson endures. In warfare, as in many complex endeavors, the ability to act quickly often matters more than the ability to act perfectly. The side that can create the infrastructure of power faster than the enemy can respond has a decisive advantage, regardless of how that infrastructure compares to theoretical ideals. The bulldozers are museum pieces now. The men who operated them are gone. The temporary airfields they built have returned to farmland or been paved over by suburban development, but the principle they demonstrated remains operationally relevant. Military engineering isn't about building monuments. It's about building what's needed, when it's needed, fast enough to matter. That lesson, learned at considerable cost in Normandy during the summer of 1944, should never be forgotten. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.